All right, I've got all the gears off of my output shaft, so I'd figure I'd just do a quick video of how all this stuff works, because it's not that complicated, but it's not very intuitive either. So okay, so input shaft, the fixed gear, I could consider that fourth gear, I guess, and then it spins freely with the synchro. This is the actual synchronizer here. It's just got this inner piece that is splined, and that attaches directly to your output shaft. So the only two parts that attach to the output shaft, right here, there's 3/4 synchro, and here is your 1/2 synchro here that's got the reverse gear on it. Everything else just spins freely. You can see it's just a bearing surface on there. None of the gears have any teeth on the inside. They all spin freely, and they're actually all connect together at the same time. That's why it's called constant mesh transmission. So let me back up a little bit so you can see a little bit. There we go. So power comes in. This is spinning all the time. It connects to your counter shaft. Counter shaft is just one big solid gear. It's 4 gears all connected. They all spin the same. So if the input shaft is spinning, it's spinning the counter shaft always. Counter shaft connects to each individual gear. So this connects to your 4th gear, 3rd gear, 2nd. This connects to your 1st gear. This is 3rd gear right here. That's going to spin freely. 2nd gear, and 1st gear is over here on the right. There, 1st gear over here. So the easiest way for the transmission to work, neutral. If you're in neutral, input shaft will be spinning with the engine. It's spinning your counter shaft. It's also spinning all the other gears. However, none of your synchros will be connected to a gear. So then the output shaft will not spin. If the synchros aren't pushed to one side, in other words, if you're not in a gear, the output shaft can't spin. But all the gears are still spinning. So let's start with 4th gear, because 4th gear is the easiest to see how the power goes through. Power comes through the shaft. Let me get this out of the way. Your synchro is splined because it's connected to your output shaft, and this blocker ring is keyed, so it's going to connect on there. And then it just rotates a teeny little bit back and forth to help line up the teeth. So when you shift, you're pushing over here with your shift fork, and it's just going to line these two up and slide over. I gotta be careful not to push it too far. There, see, now it's meshing with those like this. Looks like a sprocket on the gear shaft, on the input shaft, and now it's fixed. So power is spinning input shaft. This is solidly connected to the output shaft through here, and it goes straight through. So that's 4th gear. It's gonna be a 1-to-1 ratio. However, it's still spinning your counter shaft, still spinning all the other gears, but they're just gonna be spinning at different speeds along your output shaft. That's what makes it a little bit confusing. So this synchronizer, it just shifts back and forth one side to the other, and it connects with this blocker ring, which acts like either a clutch or like a brake, and its job is to grab onto the gear, so it makes it spin the same speed as the synchro. So if you're in neutral and you're not moving anywhere, the input shaft is moving, spinning, but the output shaft is going to be sitting still. So when you want to go into gear, it's going to put pressure on here, and when you put pressure on here, it locks it up. Like I can't spin that. So that means both of them are going to be spinning at the same speed, and then you would continue pushing that over until it slides across the teeth and it's locked together. That's basically all the synchro does. So let's see how the different gears work. here a little bit. Right there. Okay, so fourth gear, power comes in. The sinker will be slid over to lock that in. Output shaft straight out, 1 to 1, fourth gear. Third gear, power is going to come in. It's going to go down to your counter shaft, over to the third gear, counter gear I guess it's called, up the third gear. This will slide over and lock it into here. So then third gear is connected to this spline, spins your output shaft. Second gear, this is going to be back in the middle, neutral. And this is the other synchro in the back. It's the same as the front, it just has your reverse gear on the outside of it. But it works the same way. This inner part slides back and forth, like that. So for second gear, power comes in, connects to the counter shaft, over to second gear, back up to this is second gear here. And that would connect right there, lock over, slide over and lock it. And that is connected to this spline here, out. Same thing with first gear, would just go to here. This would be slid over to first gear. So it's pretty straightforward, just a lot of complicated little parts. So that's all there is to it. Just a quick video on how these detents work on these shift rails. It's kind of interesting. This is the top one. This is the middle, and the bottom one would be the reverse rail that's in there right now. These are flipped over so that you can see these detents. So this is the front of the transmission, even though I have the front facing to the left so that you can see the detent on that third rail. Right now this is in reverse, because there's the lockout right there. I'm going to show you how that lockout works. So these humps here, these are the detents for the 1-2 shift lever. This is neutral in the center, and I don't think it really matters which way, but I think this is first. No, this would be first detent, second, but it doesn't matter which one is which. It's going to move one way or the other, or it's being neutral. This is the 3-4. Those are the detents there. They face out the front of the case. There's 1, 2, 3, 4 face out through the front down here. And you can see they're offset a little bit. So right now I am in reverse. So if I was in reverse, this detent would be pushed up. See that? Because it would not fall into the notch in the V. So it's pushing up, and what it's doing is it's pushing up on this little pin right here. This is called the interlock pin. And that in turn would push up on this detent here. And that detent is going to lock into that 1-2 shift rail. That means it cannot move back and forth. This one's pushing up into this V, so that's locked. This is locked. So the only gear I can go into is reverse. And until I shift out of reverse, you cannot shift into any other gear. So then if we were to move this shifter back into neutral, this V notch would drop under the detent. That allows this detent to drop down, which in turn allows that interlock. This is just a little pin that pivots back and forth. That would allow that to drop down slightly, which in turn allows this detent to drop down out of that V. So now this shift rail is free to move, and this shift rail is free to move. So if I were to shift into first gear, this would slide. Again, it doesn't really matter which way. I think it moves. It moves to the rear. So that's pushing down on that detent right there. That detent's going to drop into that notch, which locks this, pushes down on the pin, which pushes down on this detent, which falls into the notch in the reverse rail. So all the other two rails are locked out. So put this back in the neutral. Second gear works exactly the same. To get into third gear or fourth gear, this has to be in neutral. So there's room for the detent to move up. So if I pulled back on it, it's going to push up on the detent to lock it. It's also going to push down on this detent to lock it, which again falls into that notch, locking out reverse. So it's a pretty simple operation. All these pieces have to be in there though, especially this little pin. If you lost this little pin, you would not have any lockout If you were in reverse, you could actually go into any other gear if your shifter was broken. So very bad condition, because your transmission would instantly lock up or strip your gears out, something like that. Okay, that's all there is to it.